Okay, let's go ahead and prove the Pythagorean identities today. Okay, so the most famous and I suppose most important Pythagorean identity is as follows. Okay, sine squared of alpha plus cosine squared of alpha is equal to 1. Let's go ahead and provide a quick proof for this. Okay, I think I'm just going to use a basic polar coordinate rendering here. Shouldn't be very hard to do this. Okay, let's get that nice and centralized there. Okay, so if you have standard Cartesian plane and you have a circle here, and I'll just go ahead and we're going to put in just any segment. Okay. For any point here, x comma y, we are going to have a right triangle. Okay, and without loss of generality, I'm just going to choose to use that first quadrant for convenience sake. So this will be r, this will be our alpha, this is obviously x, this is obviously y. Okay, so we know that the sine of alpha, okay, is y over r. Okay, opposite over hypotenuse. Okay, well that means, of course, that y is equal to r times the sine of alpha. All right, that wasn't so bad. Okay, we also know that the cosine of alpha is going to be equal to x over r, which means clearly that x is equal to r times cosine alpha. Okay, now we have proven the Pythagorean theorem in a past video. I'm just going to go ahead and use it right now. X squared plus y squared we know is equal to r squared. Okay, and that means, of course, that r cosine alpha all squared plus r sine of alpha all squared is equal to r squared, which means, of course, that r squared cosine squared alpha plus r squared sine squared alpha equals r squared. Notice I am using a property here. If you have a product and you raise it to a power, both factors are applied the power. Okay, this is based on a definition of exponentiation. Okay, well clearly r can't be equal to 0. If it were, we wouldn't even have a triangle here. We wouldn't even have a circle here. So I can safely divide both sides by r squared, and in so doing, we see that cosine squared alpha plus sine squared alpha is equal to 1. So there's our first statement proven. Not so bad. Let's go ahead and zoom out. Okay. Now, claim number 2, okay, that we're going to try to prove here is going to be that the tangent squared alpha plus 1 is equal to secant squared alpha. Okay, let's try to prove this. And we can readily use the statement from claim 1 that we've already proven. So let's go ahead and just establish this statement here. Cosine squared alpha plus sine squared alpha is equal to 1. Let's go ahead and divide both sides by the cosine squared of alpha. Okay, so dividing this side by cosine squared alpha and this side by cosine squared alpha, we're going to have cosine squared alpha over cosine squared alpha is 1, plus sine squared alpha over cosine squared alpha is tangent squared alpha, and then 1 over cosine squared alpha is just secant squared alpha. So we're done. We'll just use the commutative property to write this as tangent squared alpha plus 1 is equal to secant squared alpha. Okay, well that was Pretty simple. We've got our third claim, our third Pythagorean identity, and these are really the bread and butter of trigonometry, these three. Okay. The third claim is that cotangent squared alpha plus 1 equals cosecant squared of alpha. Okay. Well, again, for our proof, let's just take our original statement of cosine squared alpha plus sine squared alpha is equal to 1. Let's go ahead and divide this time both sides by sine squared of alpha. Okay. Here we divided both sides by cosine squared of alpha, and it worked. Let's now divide both sides by the sine squared of alpha. Well, cosine squared alpha divided by sine squared alpha is cotangent squared of alpha. Sine squared alpha divided by sine squared alpha is 1. 1 over sine squared alpha is cosecant squared alpha. And then, of course, let's just go ahead and use the commutative property to write this as, well, no, it's already written in the way we want it. That worked out just as we wanted. Okay, well, there you go. Not that tricky. I suppose I should point out that I am using the property A plus B over C is equal to A over C plus B over C. That's fairly evident there, right? But I should be responsible and point that out anyway. Okay. Well, there you go. Hopefully you found that video to be helpful to understand not only how these Pythagorean theorems work, but most importantly, why they work. Go ahead and feel free to leave a comment, a question, concern that you might have. Of course, recommendations for future content. We love proven statements around here from math and physics. Please have a great rest of your night, and we will see you in the next video.